Welcome to our series on exam preparation. You can always send an email to get practice test questions from us. Let's enjoy this journey. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have taken a very important question to prepare our students for final test on vectors. As you know, we adopt an approach which can help you understand and then solve similar questions whenever they pop up. So, we'll discuss the method of solving, and I'll request you to first solve the question and then look into the solution. This problem has been seen in last test paper. Well, in case you want to learn directly from me, you can always send an email on globalmathinstitute@gmail.com. We are also preparing students during the summer to get ready for the next semester. You can join those courses also. Now let's look into the question at hand. It is to find distance of a point from a line. Consider a parallelogram ABCD where A is 1, 2, 3, B is 6, 4, 5, and D is 2, 3, 4. A perpendicular line is drawn from the vertex B to the side AD of the parallelogram to intersect AD at N. Determine the length of BN. How should we solve this question? Well, first step should be sketch the parallelogram, right? Probably get an idea of how it looks like and then figure out what you really want to find, right? So it is not necessary to draw accurately the points and all. We can just sketch, rather make a rough sketch. Let's say this is our parallelogram. In exams, we don't have time to decorate things. We have to have a very practical approach. Points given to us, write it in an order. It could be clockwise or counterclockwise. So A is 1, 2, 3, B 6, 4, 5, C is not given to us, D is 2, 3, 4. We need to drop a perpendicular from B to the line AD, right? So let's say the perpendicular is like this. Is that clear to you? Now this point here is defined as N, and what we need to find is the length of BN. Perfect. So I think now the question is absolutely clear. There is no need to find point C. So do not waste your time in finding coordinates of point C. Well, that could be a good question in itself. So you can do that as an additional exercise. Perfect? Okay, great. Now, how do I find this distance from B to N? So first step is that we should know the equation of line AD, right? So we should know equation of the line AD. Then we should know coordinates of point N, correct? And then we can easily find the distance using the distance formula, right? And then we'll find the distance. Let me write Bn, which is required as square root of, you can use this formula, right? Well, but really speaking, the challenge is to find the coordinates of point n. So this is the challenge part in this particular equation. How do we do so? Well, these 2 points A to D are given to us. We can find the direction vector AD, right? So let's find the direction. Let's say D is the direction vector from, let's say, A to D. Then it should be what? Well, the difference, right? 2 minus 1, right? So we could write this direction vector as, let me use square brackets for this vector. 2 minus 1, right? 3 minus 2, 4 minus 3. Perfect. So we do get this direction vector A to D as 1, 1. This is 1, right? 1 and 1. So that becomes the direction vector. We know a point and the direction vector, and therefore the equation of the line, let's say line A to D, is equal to the point 1, 2, 3, right? Plus any parameter t with this direction 1, 1, 1. Makes sense, right? Where t belongs to set of reals. Is that clear to you? So we do get the first part, and that is equation of AD. So I hope so far everything is absolutely clear to you, right? Now, how do we find the coordinates of point n? Well, we have a general coordinate of point n. So let's move on to the next page and then work this out. So I'm not sketching the diagram again, but I guess we know the equation of the line A to D now, which is we took coordinates of point A, which is 1, 2, 3, parameter t, and the direction was easy 1, 1, 1. But beautiful question, right? Now, from here, we can get the coordinate points, right? So the x value can be 1 plus t, right? Y value is 2 plus t, and the z coordinate value is 3 plus t. Simple. Now, we need to find the distance from B, right? So, okay, let me sketch it here, a small one. So, we're now working on B to N, right? And coordinates of B are given to us as 6, 4, 5. Correct. So, since it makes a perpendicular, it's perpendicular to AD, right? The dot product should be 0, right? That's key, right? So let's find the vector Bn, the direction of vector Bn, right? So let's find the direction of vector Bn. So to find this direction, we'll take the coordinate points. So we have now 1 plus t minus the x coordinate value of 6 and 2 plus t minus 4, 3 plus t minus 5. Clear? Well, let me rewrite here itself. So 1 minus t is minus, so we get t minus 5. Here we have t minus 2, and here we have t minus 2. So that becomes the direction of Bn. Now, the direction vectors which we have now looked into, direction Bn dot direction of AD. So the dot product of these vectors should be equal to 0 since they are perpendicular. So that is the whole idea. So now find the dot product of these two, right? So we have here t minus 5, t minus 2, t minus 2, right? Dot a to d, which we just worked out. You can again calculate, right? We are looking into a to d. So 2 minus 1, it was 1, 1, 1, right? Correct. So this dot product should be equal to 0. Makes sense? Now from here, you'll get the coordinates of point D at point N. You will get T and then point N, right? So, so we can now calculate this value. So we basically have T minus 5 when you multiply with this, others are 0, right? Plus T minus 2 plus T minus 2 should be equal to 0. And that gives you 1, 2, 3t, right? And minus 9 equals to 0. And it does give you a value of t, which is equal to 3. Makes sense, right? Now you can solve this. So we know that the value of t is 3. So for point n, we can calculate using t equals to 3. So if I put 3 as my value, I get x equals to 1 plus 3, which is 4. Y is 2 plus 3, which is 5. And z is 3 plus 3, which is 6, right? So the coordinates of n are 4, 5, 6. Great. So once we have the coordinates of point n also with us, now it is simple to find the distance b to n. But you see, we have to do all these steps. Perfect. So now let's find the distance b to n. Coordinates of point n are 4, 5, 6. So now we know that coordinates of n are 4, 5, 6, and given to us coordinates of b as 6, 4, 5. And therefore, the distance b to n, which is a scalar quantity, is square root of 4 minus 6 whole square plus 5 minus 4 whole square plus 6 minus 5 whole square, correct? Which is square root of 2 square, which is 4, plus 1, right, plus 1, which is square root of 6. Makes sense. So that is how we can find the length b to n, the shortest distance from the vertex of this parallelogram b to the other side. Perfect. So that becomes our solution. So we know that this length bc, bn, is square root of 6 units. So with that, we can actually solve the question. I hope you understand the strategy. The whole idea is to review the concepts and get ready for the exam. I hope that works. Feel free to write your comment, share your views, and if you really want to have some practice test questions on vectors, send an email to globalmathinstitute@gmail.com. Just as I share with my students, I can share with you also. Thanks for your time and all the best.